Welcome, my kitties. My name is Doom, and today I will be your host. Today we'll be looking at a video by the one and only Dr. David Miano, a historian reacting to the evidence for ancient high technology. But first, a few words about myself. I am a builder by trade. I have over 15 years of experience in construction. My father operated a garden design and installation company. I later launched my own. I have extensive experience in stone, tile, and garden design and installation. I've participated in large commercial projects as well as residential. I've worked with a myriad of modern equipment, gas axes, wet saws, angle grinders, drills, jackhammers. I've played around with expansive chemicals that split stone, as well as heavy machinery, excavators, bobcats. My father and I specialize specifically in the Japanese style, and we worked a lot with creating ponds and water features. We worked a lot with basalt specifically, so I know basalt very well. We moved a lot of basalt boulders by hand, chiseled basalt, cut basalt, and granite as well. So I think I'm qualified to comment on this video, and I'm qualified to contribute to this community in general, the ancient high technology community. Okay, let's not waste any more time. Please forgive me for my sound quality. I know it sucks. This is my first video, and hopefully I will get better. So we're going to skip the first two sections of David's video here and just get right into the saw marks.
Let's get down to some examples of ancient high technology. I've grouped these examples into categories, and this will be a two-part video in order to cover as many of them as I can.
I want to ask you, the viewer, what would you consider evidence of high technology? Think about what people maybe 1,000 years from now in the future might find from our society that would inform them about our level of technology. Might they find, for example, the remains of laptops, automobile parts, fragments of planes, cell phones, broken television sets, partially preserved transmission towers, pieces of kitchen appliances, power tool parts, dead hard drives, dead motherboards, copper wire.
The thought train here is this stuff right here, these TVs and heaps of computers and plastic, is an indication of a society being high tech. And if we didn't find this stuff in Egypt, TVs, computers, and microchips, then surely nothing high tech was happening in Egypt. This is what David is trying to instill in the heads of his viewers.
Wires, broken Alexa devices, headphones, video game consoles, joysticks. We could go on, right? Now, from what I can tell, Ben believes that a society existed that had technology equal or greater to our own. Is this true, Ben? Maybe he can clarify.
I'll clarify. Ben believes there was a civilization that was global. It was pre-flood, pre-Younger Dryas comet impact. This civilization was highly sophisticated, but obviously in their own way. Vastly different technology was being utilized by that civilization than is being utilized today, and evidence for this sophisticated lost civilization is sitting in Egypt in the form of the megalithic superstructures and kilometers of tunnels bored into the ground with precision buildings like the GP sitting for everybody to see. Okay, let's move forward.
This is why it concerns me when I see people providing evidence that consists solely of looking at marks made on stones.
And I want to start with the evidence for machining. By this term, I mean the marks and indications of advanced tools that have been used to cut or shape stone blocks and objects, and these tools are definitely not found in the archaeological record. The examples take the form of saw cuts and machining marks, and tube drill holes and cores. striations and lines of varying fineness that indicate degrees of machining.
Ben speaks of machining. There were machines in ancient times, powered by humans or animals, but he clearly doesn't mean them. He seems to be talking about electric-powered or fuel-powered machines, but he remains vague about that. It's hard to judge whether a claim has merit if we don't get the full claim. Different types of machine have different tells, right? If we're going to be able to distinguish between a machine powered by humans or animals and a machine powered by whatever Ben thinks they were powered by, we need to know how the marks on the stone would differ. And hopefully it will be something we can measure instead of just eyeball. Ben doesn't equip us with that information before going in. I watched the whole video and still don't know how the tools he is envisioning were powered.
Ben is not supposed to equip you with information on the power sources for the tools that were lost, right? This is not what the ancient high technology community is doing. What the ancient high tech community is doing is eliminating chisels, drag saws, and pounding stones from the tools utilized to raise the superstructures that are sitting in Egypt. The millions of tons of blocks, the hundreds of thousands of tons of granite that were shaped, cut, and fitted perfectly.
But also for the power sources and the means for conveying that power.
Many of the objects with such marks come from sites known to exist during the Old Kingdom period of ancient Egypt, or from other parts of the world that also had an equivalent Bronze Age technology, typically with no access to iron or steel tools. The tools that are found that come from these periods are primitive hand tools, flint knives, copper or bronze chisels, adzes, or stone pounders. These do not produce machining marks, and clearly none of them were mechanized or powered.
Question for Ben. If these objects could be made with iron or steel tools, would you concede that electrically powered or fuel-powered machines were not necessary to make these objects? Remember now, if you want to date these cuts to an entirely new hypothetical time period, you have to not only disprove that they were made in the Bronze Age, but you have to disprove that they were made in all ages other than your own.
What's more, the Old Kingdom was not thought to have had access to the wheel, yet in many Old Kingdom locations we can see the evidence for precise and powerful tools that certainly operated on principles involving the wheel and that seem to have cut through incredibly tough material like granite, diorite or basalt with seeming ease.
The Old Kingdom had circular objects, even machines with circular parts. There's a difference between not using wheels and not knowing what a wheel is. The Egyptians interacted with their neighbors, and their neighbors did have wheels. So they knew all about wheels. They just preferred to use their watercraft for travel.
Some of these machining marks left consistent and measurable arcs that we can use to estimate the saw's size. And these tools must have been truly monstrous. They must also have been powered by some mechanism.
He's implying that the blades were so humongous that they could not be turned fast enough by human-powered machines.
He's not implying that at all. He never said that. He just indicated that these saw marks imply a large saw blade. Circular saw or a swing saw. I don't know where you got that from. You just made that up.
Machines. Size is a big part of his argument. Let's see how he uses the measurement of the arcs to determine the size of the tools.
Perhaps my favourite example of what must have been just a huge circular saw, or perhaps a swing saw, is found at the Old Kingdom site of Abu Sir. This megalithic block of basalt that sits in front of one of the several pyramids on that site looks much like many others that are found here, yet a close examination reveals some astonishing characteristics.
Ben never says in what part of Abu Sir he is or what building this block comes from, so I had to go find out for you. This block was part of the lower portion of a wall from the funerary temple of King Niuserre from the 5th dynasty in his pyramid complex. Interestingly, blocks of the same type with these distinctive cuts are found not only here at Abu Sir, but also at Giza, most notably in the temple on the east face of the Great Pyramid. Archaeologists have examined and measured them all in order to form an educated opinion about these blocks and how they were cut. Ben will be pleased to know that they've concluded that the markings were indeed made by a saw blade.
Archaeologists? You mean those guys that have no expertise in machining, stone cutting, engineering, and construction in general? Those guys? 2 seconds to determine that they use saws. The question is, what kind of saws? What were the feed rates? Are these saws present in the archaeological record? Which, of course, they're not.
2 of the blocks have near vertical plunge cuts, which definitely indicate the work of a saw. So far, so good. The shape and size of the saw is important here. A large circular blade would be more likely to have been powered electrically than, say, a drag saw, which could very well be human-powered. The good news is that archaeologists have been able to ascertain the kind of saw and the size of the saw from these marks.
The archaeologists already solved the puzzle. What are we doing here, man? Oh my god, where is this groundbreaking research? Show me. UnchartedX, shut it down, dude. Everything's been solved. The archaeologists already figured it all out. They don't have the saws, but they figured out exactly what type of saws.
Rapid rate of cutting. The speed of the cutting is the key here. But how can we determine how fast the stone was cut? Ben never says. Showing the evidence for rapid cutting is essential to his argument. He refers to obvious striations and grooves as if that were enough. But any saw, fast or slow, can make striations. Striations are not speed marks.
You mean feed rate marks? In this case, I don't think these striations determine a feed rate. I think they look pretty mangled. I think more research needs to go into this stone.
So his argument is half-baked. In order for us to know whether these marks were caused by a power saw, we need distinctive characteristics unique to power saws. With a measurable standard, we would be able to say, this has been done by a power saw, whereas this has been done by hand. Otherwise, it's just an exercise in imagination.
The block appears to have not been...
An exercise in imagination is archaeologists determining the types of saws that were used there. That's an exercise in imagination.
cut all the way through, something that we are very fortunate to have evidence for, as it also appears to have been a remarkably thin edge, only a few millimeters of material, as evidenced by the lip that is left on the edge of this block.
This raises a whole bunch of questions. If I understand him correctly, Ben is saying that the slightly curved cut is an indication of a giant circular saw that plunged vertically into the stone and did not, in any way, move horizontally. This is not the usual action of a circular saw. Usually, it starts on one end and progresses all the way to the other side. It doesn't just dip into the center, unless the use of a circular saw. Usually, it starts on one end.
This is why we can't have historians commenting on machining and saw marks. First of all, this blade that he's got on the diagram here is a blade for cutting wood. You would find this blade typically on a chop saw or a skill saw. If you took this blade to a stone, it would immediately detonate and these teeth would end up in your face. That's not the point here. The point is here is he's absolutely dead wrong. When you're cutting stone, you plunge the saw from the top down into the stone. Typically when you have a wet saw, you have a slab, a stone, or a tile on a slider tray. You take a soapstone and you mark it out right in the middle of that tile. Then you bring the blade to that mark, turn on the saw, and you make a score line up and down the top of the stone. And then using the saw or the slider tray, depending what type of saw you got, you go back and forth, boom, 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 until you cut all the way through. You never jam the blade at the beginning and push it through the tile. That's not how it's done. That's a gnarly and sketchy and an imprecise way of doing it.
And progresses all the way to the other side. It doesn't just dip into the center, unless the user deliberately wants to make that specific cut. Ben says he thinks this was an unfinished cut, but if this were cut by a rapid process, The implication Ben is making is that it would have taken just a few minutes. Why would they have stopped it 3 seconds before finishing? Surely it would have been easier to just go all the way through.
This is conjecture stacked on top of conjecture. They could have stopped that cut for a myriad of reasons. They could have went for a smoke break and then got fired. The company could have gone bankrupt. A comet could have struck the construction site and that was the last stone they were cutting. But a likely possibility is the stone, under its own weight, broke in two when it got to that very thin spot. And they were like, oh, sweet. Grab that half, that's the one we need, and this one is garbage. The fact that they didn't go all the way through means absolutely nothing.
Instead of stopping the saw right before the end.
Look at the arc to the saw and just try to imagine the diameter of the tool. If it was indeed a circular saw, it may have been as much as 8 or 9 meters or 25 feet or more in diameter.
Ben appears to be calculating the...
Sorry, a better question is, if they were using a copper drag saw and they sat there for months doing it, why didn't they go all the way through? Why go through so much work and not finish the slab?
Estimated by Christopher Dunn to have been made with saws up to 11 meters in diameter, which is over 30 feet. Primitive hand tools made from copper, indeed. I think
that 11-meter cut is in the Sphinx enclosure. I remember seeing it somewhere. It is massive. It's insane. Just looking at this slab, you can tell that this cut was done in a single pass. And what I mean by that is the stone was absolutely stationary, and so was the saw. They didn't switch out the blades or the stone. It was done in a single pass. I don't know how long it took, but it looks clean. The saw that was utilized here is massive. And it was obviously proficient, and it was very thin, which screams sophistication. If the saw blade is very thin and you're using it to cut a slab this big, right, you're doing something advanced. Also, not a single stone milling facility would produce one of these arcs today. We don't have anything like that. We don't have circular saws this big. So this is a strange anomaly. If this was done by a large copper swing saw, I would have to see it in action, and then we would have to look at the striations left by that copper swing saw. Otherwise, nothing has been determined about this cut. Zero. You can't eliminate anything here.
this particular block was never quite finished.
Okay, so he's letting us know that Christopher Dunn has done some measuring on other objects. But since we aren't told what they are, I can't really address those here. However, I would be surprised if Dunn's measurements are as accurate or as exhaustive as that done by archaeologists. Besides, the nature of the markings rules out a rotating blade. As far as a drag saw is concerned, did it need to be powered by something other than humans? No, it did not. There's a thorough discussion of the evidence from these stones by Robert Moores that I will link below for any who are interested in investigating this further. Moores posits that the cuts were made by a copper drag saw about 4 meters wide and 60 centimeters
Now that's an exercise in imagination.
broad with a weight of 140
And I'm all for it. I'm all ears.
kilograms. Whether this is exactly how it was done is irrelevant to my point, which is that Ben has provided insufficient evidence of rapid cutting and insufficient evidence of a rotating blade, while Moores has provided sufficient evidence for a drag saw of some kind.
He just drew some diagram. That's sufficient evidence to tell me that this is how this stone was cut? No, it's not. Absolutely not.
And it seems likely to me that many of the other basalt blocks that form part of the megalithic floors and walls on this site were likely cut in a similar fashion, and then they were polished to an astonishing level of flatness, which removed the grooves and the striation marks from the cut.
UnchartedX is referring to basalt stones of the same type as the ones we've discussed already. So, just more of the same. He brings up polishing for the first time. He will again. So this is a new evidence of machining, I guess. But does Ben believe that polishing can be done only by machines? I wouldn't think so. At this point, I can only assume he has found evidence of high-speed polishing. I am curious how he determines how fast the polishing was done. Since this is clearly a street, probably in use for centuries, then the surface of the rocks would be affected by people walking on them every day. You ever see stone-paved roads or walk paths that have been used for a long time? They wear, right? So why is he examining their surfaces as if they haven't been touched since they were made?
At Giza and on other sites, we have actual saw cuts that were started and not finished.
I wanted to say a few words about this stone in particular. It looks like it's maybe a piece of quartz or something, maybe limestone. But this cut is highly anomalous. A drag saw would always get jammed in a cut like this. As you're pushing through it, it will always get jammed. If you have ever been jammed just hand sawing a 2x4, sometimes hand saws, they just curve a little bit and you're like, and you're breaking the saw and it's bouncing back and forth. With stone, it would just get worse. So this is a highly unusual cut in stone. I've seen lots of these all over Egypt and Peru. And it seems like they were just doing this all the time. Like, we'll just make a curve cut. No, this is an insane cut that you would never see on a modern mill, stone milling facility. You could suppose that this was a massive tube drill that just finished that circle, right? It was just bam, but that's an absurd piece of equipment. So again, this is a very thin curve cut like that. I couldn't produce this cut with any machine that you give me today, unless it's a water jet saw. So determining that this was actually done by a saw, I wouldn't bet my index finger on it. Like if the little saw guy wheeled out on his little bike and he's like, I want to play a little game. You have 1 week to make this cut right here in stone. And here's a copper drag saw. Here's an iron drag saw. And here's an angle grinder. Go. You would die, right? You would get killed because you would not complete the challenge. This is a trip in of itself, but this is one of hundreds of stone anomalies that I've seen. This is nothing. I'm gonna look into more of them later. Let's continue.
The basalt floor to the east of the Great Pyramid has several such marks made into it.
Just a reminder that we all agree that these are saw cuts. The disagreement is about how fast.
I don't agree. I just said that saw cut was very weird. Could have been a water jet saw, water jet cut.
They were cut. And please also note that many of these cuts are not straight. What does that indicate?
A close examination of the granite box inside the King's Chamber of the Great Pyramid also reveals the striations and markings of great saws that were used to cut and shape it.
Okay, we're just gonna skip this Khufu box, blah 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 blah, and get a little bit further into this response to new evidence section. I just want to take a look at more saw.
Moores proposes a blade made of...
So this is the exercise in imagination by expert archaeologists. Moores just produced this thing out of thin air. He's got all the specs on it. It's all planned out. Just looking at this diagram, just a couple of things before we get into the saw. So they have water here. I'm guessing that's to lube it up so it doesn't burn out the blade. It's easier for the blade. They got some stones holding the target stone that they're cutting. I've moved lots of stones, like large boulders, by hand with multiple people. Like a whole crew would get on one boulder without machinery, right? In some nice backyards where you can't get excavators back there. Number one rule with boulder moving or large rock moving is never get it into a hole. Once that rock is in the hole, you can forget about it. You can just throw some dirt on it and say goodnight. We're talking about 20, 40, 80, 120 ton blocks going into some slush hole, right? And then being taken out. Like, okay, get the next one in. This one's done. Take it out. Next one in. Right? These people, they just draw these diagrams, but they have no connection to the real world.
7 inches 4 meters long and 23.6 inches 60 centimeters broad, and was wedge-shaped from 0.393 inch 1 centimeter at the top to 0.118 inches or 3 millimeters at the cutting edge. Morse estimates the weight of the blade was 308 pounds or 140 kilograms. Quartz sand was used in the process as an abrasive. It was rubbed against the basalt both as a loose medium and also by quartz sand that was embedded into the copper. This process, with fresh sand being added to the cut as used sand and sawed rock was flushed away, impressed the shape of the blade into the basalt. As we see in the figure, a team of workers dragged a blade across a block that was fixed inside a trench filled with water. The blade was suspended on ropes that were controlled by workers, who, according to Morse, managed the blade's incremental descent into the basalt." End quote. Just with this description of the blade and the image of its theoretical operation, you can begin to imagine some of the practical mechanical problems with this proposed solution. And this is only the beginning of the issues with the mainstream explanation. Quote, "It is hard to imagine the successful employment of the physics of a pendulum on a swinging 308-pound object that ultimately is met with a hard, solid surface covered in sand."
When the process starts, the blade is not going to ram into the hard surface. It's going to scrape the top. What's hard to imagine about that?
If we take into consideration the fact that the blade is wedge-shaped, which would mean its increasing width would impede its progress into the slot, the impossibility of the operation becomes more evident. End quote.
I don't see the logic of his statement. As the blade descends into the cut created in the stone, the sides of the blade will rub against the stone. This will keep the blade sharp, and the width of the blade will be reduced from the friction. Dunn's argument flies in the face of everything we know about stone cutting using a saw of this type.
This diagram flies in the face of everything we know about stone cutting. First of all, this looks like a wooden saw again with large teeth that would be absolutely mangled the moment they hit stone. I don't know what they're cutting here. Cheesecake? David, did you draw this diagram? Be honest. If you were to use a handheld saw like that on stone, the teeth would have to be tiny. Okay? Lastly, the teeth, they create a slot for the saw to go through. So this saw actually goes through whatever it's cutting unimpeded, virtually with no friction. It just gets a little bit warm. It doesn't self-destruct like the wedge-shaped copper saw that you just said yourself would reduce in size as it goes through the stone. So this saw is reusable, it's live, yes, they use it, but this diagram looks a little bit bobo, I'm not gonna lie, and has nothing to do with a copper drag saw. But let's go forward.
Stone cutting like this has been practiced all through history. There's never been a problem with the blade's progress being impeded.
Where it gets truly ridiculous is with Moore's claimed rate of cutting with such a setup. Admittedly, he does state that this is the best case estimate, but according to his paper, a single cycle of this saw, one back and forth motion, would cut 2 millimeters into the basalt. and with a swing time of around 2.84 seconds, it would cut at a rate of 42 millimeters or 1.653 inches per minute. Let's put some of these rates into context. As explained by Chris Dunn, United States patent number 7082939, filed in 2003, describes an improved frame saw using carbon alloy steel blades impregnated with diamonds, and cites a downfeed rate into granite of 30 millimeters or 1.18 inches, not per minute, but per hour. This modern rate of granite cutting using powered saws with diamond...
Hey David, look at that saw. You see how it's sitting on top of the stone and going back and forth? And not jamming itself at the beginning and going forward?
Tip blades is 84 times less than the rate cited by Moore with his copper drag saw using...
So Moore's imagined a saw. Let's just put this into perspective. He imagined a saw and then determined that it would be 84 times faster at cutting stone than this thing. This is the expert, educated archaeologists doing Egypt. Incredible, incredible work.
Sand and human power. Like I said, it's truly ridiculous. And bear in mind here that we're also comparing the modern rate of cutting into granite, while Moore is citing a rate of cutting into basalt, which is harder and therefore even more difficult to cut than granite.
That's just false. Granite is harder than basalt. I don't know where he's getting this from, but Google it. Basalt is softer. It's easier to cut.
Wrong. Where David got this is he Googled basalt is rated 6 on most scale and granite is rated 6 to 7, I'm guessing. But in fact, I did find sources that rated basalt, some varieties of basalt, 7 on most. I've even seen a 6 to 8 rating of basalt on most scale. But besides that, basalt has tensile strength twofold that of granite. It has flexural strength higher than granite. It is more dense than granite. And it is absolutely 1,000,000% harder to chisel than it is to chisel granite. I've done it. I've mangled chisels doing it. Show you a photo. I was screwing around on this project. This is a little 3-stage waterfall that we built. My dad's like, take this corner out, take that corner out, take this corner out, and my chisel, my tempered steel chisel, was damaged. Like, it was no longer sharp. Basalt is one of the baddest stones out there, and in terms of cutting it with a grinder or a wet saw, there is absolutely no difference between granite. They both cook diamond blades like no other. And no, basalt is not softer than granite. So all of this work is nullified and Ben is dead wrong. But David latches onto this and swings off it like a baboon for the next little bit here.
This is not to say that I think Moore's estimate is correct,